Greetings everyone. Welcome to E&E Learning Hub. I'm going to go through and explain the solutions for question 4 from the 2017 CSEC Electrical and Electronic Past paper. So let's begin. Part A. It says define each of the following terms. Part 1 of A, fusing current. So this is the current required to melt the fuse element inside a fuse. Part 2 of A, fusing factor. This is the ratio of minimum fusing current and the current rating of the fuse. Part 3 of A, illumination. This is the energy of light striking a surface of specific unit area. Part 4 of A, luminous flux. This is a measure of the total amount of light a lamp is able to emit. Part 5, primary cell. This is a cell that cannot be recharged with electricity once discharged. Part 6 of A, secondary cell. This is a cell that can be recharged with electricity after being discharged. So that's it for part A. All right, so let's now move on to part B. It says a 3000 CD light source is suspended 4 meters above a plane surface. Calculate the illumination, part 1 of B, on the plane surface directly below the lamp. All right, so I am going to draw a graphical representation of what they are asking for. So here we have a lamp, and this is the plane surface that is directly below the lamp, or the lamp is above that plane surface, and the distance between the lamp and the plane surface is 4 meters. All right. The luminous intensity of the lamp, which is I, equal to 3000 CD. So what the question is asking for is the illumination of the lamp on the plane surface directly below it. So to calculate the illumination, E is equal to luminous intensity divided by the distance squared. And that distance is the 4 meter. So 3000 CD divided by 4 meters square, that will give us 187.5 lux. So that's the illumination on a plane surface directly below the lamp. All right, so that's it for part 1 of B. For part 2, on the plane surface 4 meters from the center of the lamp. So we now need to calculate the illumination on the plane surface 4 meters from the center of the lamp. All right. So let's also add that to the diagram. So from the center, 4 meters. So this is 4 meters. Now this will be at an angle. All right, so the angle will fall here. Now, in order to calculate the illumination, we must calculate the distance, which is D. So we're going to call that D. We're going to call this side H, and this side down here going to call it B. So the first thing we're going to do is to calculate the distance. So D is equal to the square root of H squared plus B squared. That will give us square root of 4 squared plus 4 squared equal to the square root of 16 plus 16 equal to square root of 32. So the square root of 32 is 5.66 meters. So D here is equal to 5.66 meter. Now, before we can calculate the illumination, we have to now consider the angle as well. So because we're going 4 meters away from the center, it means that the amount of light that will be striking that plane surface will now be at an angle. So we now have to take that angle into consideration. So to calculate the angle, cos theta is equal to h divided by d. So we know what h is, that is 4 meter. We know what d is, that is 5.66 meter. And 4 divided by 5.66, that will give us 0.707. So now to get the angle, theta is equal to cos inverse 0.707, and that will give us an angle of 45 degrees. Now that we have those values, we can go ahead and calculate the illumination on a plane surface 4 meters from the center of the lamp. So E is equal to I divided by D squared cos theta. So I is 3000 CD divided by the distance, which is 5.66 meters squared, multiplied by cos theta, which is 0.707, and that will give us 66 lux. All right, so that's the illumination on a plane surface 4 meters from the center of the lamp. Now, what these two information is telling us is that the further away you are from the light source is the less illumination you'll have. But the closer you are to the source, meaning that the light source is directly above the plane surface, more illumination you will have. Because if we look at the calculation for part 1, the illumination is 187.5 lux, and that is when the light source is suspended 4 meters above the plane surface. For part 2, the illumination is 66 lux, and that is when you go 4 meters from the center of the lamp. All right, so that's it for part B. All right, so let's now move on to part C. So it says, with the aid of a diagram, outline how a polarity test can be conducted on a completed electrical installation before it is connected to an AC supply system. All right, so here I have 2 diagrams to aid with the explanation of how the polarity test is done. So for the first diagram, as you can see here, the ohmmeter, one of the lead for the ohmmeter, is placed on the terminal for the phase conductor, and the other lead is placed on the first terminal of the switch. Now, with that, you should be getting a low resistance reading on the meter. For the second diagram, with the switch toggled in the on position, with one lead of the ohmmeter on the terminal of a phase conductor and the other lead to the terminal of the lamp holder, should be getting a low resistance reading on the meter as well. So this is how you would conduct a polarity test on a completed electrical installation before the AC supply system is connected to it. All right, so that's it for part C, and that's it for this question.